The formula for mode of grouped data. Welcome, everyone. Today, we are moving forward in our study of statistics to tackle a more precise topic, the formula for the mode of grouped data. Now, if you recall from our previous lesson, we learned how to identify what we call the modal class. This is simply the class interval that has the highest frequency, the one where the most data points are clustered. However, there is a limitation we need to address. Identifying the modal class only gives us a range or a window of where the mode might be. It doesn't give us a single exact number. To find the specific, precise value that represents the mode for the entire dataset, we cannot rely on observation alone. Instead, we must use a mathematical formula. As we move into the next slide, you will see this formula. It is a powerful tool that allows us to pinpoint exactly where the mode likely lies within that modal class by looking at the frequencies of the classes immediately surrounding it. Let's take a closer look at the math behind this. The mathematical formula. Now that we understand that the modal class only gives us a range, we need a way to pinpoint the exact value. To do this, we use a specific mathematical expression. Looking at the screen, the formula for the mode is equal to L plus, all over to the numerator, f sub 1 minus f sub 0, divided by the denominator, 2 times f sub 1 minus f sub 0 minus f sub 2, and finally, we multiply that entire fraction by h. It might look a bit intimidating at first glance, but don't worry. In the very next slide, we are going to break down exactly what each of these symbols represents so you can use it with confidence. Understanding the notations. Now that we have seen the formula on the previous slide, you might be looking at all those letters and wondering, how do I know which number goes where? Well, to use this formula correctly, it is essential to understand exactly what each symbol represents. Let's break down these 5 key components one by one. First, we have the lowercase letter L. This represents the lower limit of the modal class. To make this clear, if you identify your modal class as the interval 20 to 30, then L would be 20. Second, we have f sub 1. This is the frequency of the modal class itself. If you look at your frequency distribution table, this is simply the highest frequency value you can find. Third, we have f sub 0. This is the frequency of the class preceding the modal class. In simpler terms, it is the frequency of the interval that comes immediately before your modal class in the table. Fourth, we have f sub 2. This represents the frequency of the class succeeding the modal class. Just like the previous one, but in the opposite direction, this is the frequency of the interval that comes immediately after your modal class. Finally, we have the letter h. This stands for the class size, which is also known as the class width. To find this, you just calculate the difference between the upper limit and the lower limit of any class interval, assuming they are all equal. For instance, if your class is 20 to 30, then h equals 30 minus 20, which gives us 10. Once you have these 5 values identified, you'll be ready to apply them to a real-world example, which we will look at in the next slide. Real-world application example. Now that we have understood the formula and all its individual components, let's see how this works in a practical, real-world situation. Imagine a logistics company that manages a high volume of shipments. To optimize their automated sorting machinery, they need to identify the most common weight range for the parcels they process. In this specific scenario, they have analyzed 50 parcels processed within a single hour. Take a look at the frequency distribution table provided here. On the left, we have the weight intervals measured in kilograms, and on the right, we have the number of parcels, which we call the frequency, that fall into each weight range. We can see that for the range 0 to 10 kilograms, there are 5 parcels. For the 10 to 20 kilogram range, there are 12 parcels. Then, we see a jump to 20 parcels in the 20 to 30 kilogram range, followed by 8 parcels in the 30 to 40 kilogram range, and finally, 5 parcels in the 40 to 50 kilogram range. Keep this table in your mind, because in the next few slides, we are going to use these exact numbers to walk through the step-by-step calculation to find the precise mode. Step-by-step calculation. Now that we have our real-world scenario and the frequency distribution table in front of us, let's begin the actual calculation. The very first step in this process is to identify the modal class. To do this, simply scan down the number of parcels column and look for the highest frequency. As you can see in our table, the highest frequency is 20. Now, we look horizontally to see which weight range that 20 belongs to, which is the interval from 20 to 30. Therefore, we can conclude that our modal class is 20 to 30. Keep this class in mind, because we will need to extract specific values from it in the next step. Step-by-step calculation continued. Now that we have successfully identified our modal class as 20 to 30 in the previous step, we need to move on to step 2. This step is all about extracting the specific numerical values we need to plug into our formula. Let's look closely at our frequency table and pull out the variables. First, we need the lower limit of our modal class, which we call L. Since our modal class starts at 20, L equals 20. Next, we need the frequency of this modal class itself, represented by F1. Looking at the table, the frequency for the 20 to 30 interval is 20, so F1 equals 20. Now, we must look at the classes surrounding our modal class. We need the frequency of the preceding class, which is the one immediately before, called F0. Looking just above our modal class, we see the frequency is 12, so F0 equals 12. Then, we need the frequency of the succeeding class, which is the interval immediately after, represented by F2. Looking just below our modal class, we see that frequency is 8, so F2 equals 8. Finally, we need the class size, which we call h. This is the width of our interval. We calculate this by subtracting the lower limit from the upper limit of our modal class, so 30 minus 20, which gives us a class size, h, of 10. Keep these 5 values in mind, because in the next slide, we are going to substitute them directly into our mathematical formula. First, we need the lower limit of our modal class, which we call L. Since our modal class starts at 20, L equals 20. Next, we need the frequency of this modal class itself, represented by F1. Looking at the table, the frequency for the 20 to 30 interval is 20, so F1 equals 20. Now, we must look at the classes surrounding our modal class. We need the frequency of the preceding class, which is the one immediately before, called F0. Looking just above our modal class, we see the frequency is 12, so F0 equals 12. Then, we need the frequency of the succeeding class, which is the interval immediately after, represented by F2. Looking just below our modal class, we see that frequency is 8, so F2 equals 8. Finally, we need the class size, which we call h. This is the width of our interval. We calculate this by subtracting the lower limit from the upper limit of our modal class, so 30 minus 20, which gives us a class size, h, of 10. Keep these 5 values in mind, because in the next slide, we are going to substitute them directly into our mathematical formula. Step-by-step calculation continued. Now that we have successfully extracted all our necessary values from the frequency table, identifying our lower limit, our frequencies, and our class size, we move on to step 3. This is where we bring everything together by substituting those specific numbers into our mathematical formula. If you look at the screen, you'll see the formula being populated. We start with our lower limit, which is 20. Then, we add the fraction part of the formula. In the numerator, we subtract the preceding frequency, 12, from our modal frequency, 20. Moving to the denominator, we take 2 times our modal frequency of 20, and from that, we subtract both the preceding frequency of 12 and the succeeding frequency of 8. Finally, we multiply this entire bracketed expression by our class size, which is 10. It might look a bit complex at first glance, but as you'll see in the next slide, we will break this down step by step to reach our final answer. Step-by-step calculation continued. Now that we have successfully substituted all our identified values into the formula in the previous step, we move on to step 4, which is performing the actual arithmetic calculations. Let's take this one piece at a time. First, we need to focus on the operations inside the parentheses, specifically solving the numerator and the denominator. Looking at the top part of our fraction, 20 minus 12 gives us 8. Now, let's look at the bottom part, the denominator. We take 2 times 20, which is 40, and then subtract 12 and 8, leaving us with 20. With those simplified, let's substitute them back into our main equation. We now have the lower limit of 20 plus the fraction of 8 over 20, all multiplied by our class size, which is 10. To finish this off, let's simplify the fraction. 8 divided by 20 simplifies to 0.4. When we multiply 0.4 by our class size of 10, we get 4. Finally, we add that 4 to our starting lower limit of 20, which brings our final result to a mode of 24. So, the most common weight for the parcels in our logistics example is 24 kilograms. Keep this calculation in mind, because in the next slide, I'll highlight some common pitfalls where students often make mistakes during this very process. Common mistakes to avoid. First, a very common error is confusing F0 and F2. When you are looking at your frequency table, students often accidentally swap the preceding frequency, which is F0, with the succeeding frequency, which is F2. To avoid this, always double-check your work. Remember that F0 is the frequency that comes immediately before the modal class, and F2 is the frequency that follows it. Second, be careful with your lower limit. Represented by the letter L, you must ensure you are using the lower limit of the modal class specifically. Do not accidentally grab the upper limit of that class, and certainly do not pick a limit from a different class interval. Third, pay close attention to your calculations in the denominator. A frequent mistake is forgetting to multiply the modal frequency, F1, by 2. When you are calculating the bottom part of the fraction, make sure you calculate 2 times F1 first, and then subtract F0 and F2. If you miss that multiplier, your entire fraction will be incorrect. Finally, always respect the order of operations. To get the correct result, you must first solve the operations inside the parentheses, the subtraction in the numerator and the denominator. Once you have that fraction, multiply it by the class size, H. Only after that multiplication should you add the result to the lower limit, L. Now, before we wrap up today's lesson, I want to pause and discuss some common pitfalls. Even when you understand the concept, it is very easy to make small errors that can lead to the wrong answer. Let's look at 4 specific mistakes to watch out for. If you follow these steps carefully, you will avoid these common traps and arrive at the correct mode every time. Now, let's move on to our final summary of the key takeaways. Key takeaways. First, remember that when we are dealing with grouped data, the mode isn't just a broad range like the modal class we identified earlier. It is a specific, single value that we estimate to lie somewhere within that modal class. Second, keep this formula close to heart. Mode equals L plus all over f sub 1 minus f sub 0 divided by 2 f sub 1 minus f sub 0 minus f sub 2, all multiplied by h. This is the standard mathematical method you'll need to follow for your curriculum and exams. Finally, here is a very important tip for checking your work. Your final answer must always fall within the boundaries of the modal class you identified at the start. For instance, in our earlier example, our modal class was 20 to 30, and our calculated mode was 24, which fits perfectly. If you ever calculate a mode that falls outside that range, stop immediately and check your steps, because it means there is an error in your calculation. All right, we have reached the end of our lesson, so let's wrap everything up with some key takeaways to ensure you've mastered this concept. Great job today. Keep practicing these steps, and you'll be an expert in no time.